Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, and Wireless Essentials version 7 course curriculum, or the second of the 3 Cisco Networking Academy CCNA courses. And in this Packet Tracers activity, we're going to be taking a look at Packet Tracer Skills Activity number 4. This is our final skills activity for the semester and for this course. So let's dive in and take a look at the topology as it exists. And so you can see here we've got sort of LAN A to the left and LAN B over here to the right, connected into router 2, which is segregating or separating these broadcast domains. And then router 2 is connected via a serial link to router 1 that has redundant serial connections to the ISP. So everything we need to complete the activity is right here. The only thing I'm going to do is move these up just a little bit so that you're able to see the completion percentage down in the lower right-hand corner. And again, if I click on this, you can see that the only thing we're missing when I highlight the routers to bring them up is that the little note here, the skills exercise, is complete. So let's dive in here. Step 1, configure static default routes on router 1 and on router 2. So let's dive on to router 1 here, and we are going to be configuring an IPv4 default route, static default route, using the exit interface serial 000. So let's go from user exec with the enable command into privilege exec, and then with the configure terminal command, we transition into global config mode. And it's here where we're going to use the IP route with the quad zeros, and then the outgoing interface, or the exit interface, which is that serial 000 interface. And when I hit enter, you can see we've been given 10 points. Now, we also receive this message, which is sort of a ubiquitous message that you'll get sometimes when you're configuring your static routes, and that is default route without gateway, if not a point-to-point interface, may impact performance. Well, these are serial point-to-point interfaces, so there is going to be no impact or performance. In fact, if that was Ethernet cabling between these two, they would still be considered point-to-point. There's no switch in between there. There's no broadcast domain, so to speak. So we could get away with point-to-point interfaces using Ethernet cables as well, which as soon as we start the ENSA version 7 course with the OSPF, you're going to see that that is exactly what we're going to be doing with OSPF as well, those point-to-point interfaces. So there is our static default route with the outgoing interface. Now, on router 1, we're going to configure a floating static default route, and this is going to be the route that's going to come into play if, for whatever reason, that serial 000 interface goes down. So let's go ahead, and I can actually just recall the command, change the interface, and let's do a question mark here. And you can see, what is the administrative distance metric for this route? Well, by default, static routes have an administrative distance of 1, and so we're just going to make it something greater than that, meaning this static default route will not be installed into the routing table. Right? It'll be standing by, sort of a cold standby, so to speak. You might think of it as a hot standby. Since it's there, it's configured, but it's going to have to be pulled into the routing table, and we pick up another 10 points there. So we've got both of our static routes. Let's say do show IP route, and let's see what everything looks like here. Well, there is our static default route, and you can see that it's set to go out the serial 000 interface. So you might be asking yourself again, well, what about the other static route we configured? Well, that is one that we're only going to see if this interface goes down, and then the other floater, that floating static default route, would be pulled into the routing table automagically for us. All right, so on router 2 stub router, here's our router 2 stub router, let's configure an IPv4 default route. And does that not make perfect sense right here? Because how many ways does router 2 have to get up here to router 1 and then over to the internet service provider? Router 2 only has one option here. So I don't need to put in a whole bunch of longer, more specific static routes. The only thing I need here is to tell Router 2, hey, if you get traffic for which you don't have a longer, more specific match, then just throw it out the serial 00 interface over to Router 1. We'll let Router 1 deal with that traffic. And this is a perfect use case right here where a static default route is a beautiful solution and best fits this use case. So let's get into global config and let's say IP route quad zeros, and it wants us to use the next hop IP address. In other words, the Router 1 serial 011 interface here. And you can see we've got the subnet information and they've been kind enough to provide that last octet value. So it should be 10.10.20.1. And it is a /30, so there's only two usable IPs in here. It's going to be .1 and .2. .2 being on Router 2, .1 being on Router 1. And we'll know right away when we hit enter and we pick up our 10 points there. So we've got that configured. The final thing we're going to do is we're going to configure an IPv4 static route to the 10.10.16.0/24 network using the exit interface serial 011. And we're going to do that here on Router 1 because we have to tell Router 1 how to get back to these two networks down here. Again, let me real quickly, let's pull this static route off of here because I want to demonstrate something for you. So now there is no static route. So if I pull the PC up, and let's bring our PC down here, and I was to say ping, and let's ping that 64.100.100.1. That is the message in the previous packet tracer tutorial that we looked at, packet tracer tutorial 16.3.1. I talked about this message a lot. Reply from 10.10.16.129. Well, who is 10.10.16.129? Well, if I'm on PC2, it's got to be in this broadcast domain, this subnet, right? So it's going to be this interface right here. It's the router. It's the router telling me, hey, I've received your IPv4 packet that you're trying to send to the 64.100.100.1. However, when I look in my routing table right now, do show IP route, I don't have a route to get there. I don't know what to do here with this traffic. So I'm dropping the traffic, but I'm going to be kind enough to reply to you and let you know, hey, I don't know how to get there. That destination host is unreachable. I don't have a route, static or otherwise, that can tell me what I'm supposed to do with this traffic to help you get to where you're trying to go. That is a much different message from the one that we receive when we do have a static default route here. So now when I say do show IP route, there it is. This is my catch-all. This is my fail-safe. This is my Hail Mary. That if Router 2 gets some traffic and it doesn't have a longer, more specific match on how to reach that destination network, it says, hey, that's cool. I'm just going to throw it out the serial interface, serial 000. I'm sending it up to Router 1. Who's 10.10.21. That's the IP, the next hop IP for any traffic that I don't have a longer, more specific match and I don't know how to get there. That's what's going to happen. So now on the PC, we no longer see reply from 10.10.16.129 telling me that it doesn't know how to get there, that the host is unreachable. Now I'm getting the message that says request timed out. And what's happening here is I've sent my ICMP echo request, but I'm not getting a reply back. No ICMP echo reply coming back. And the reason for that is that Router 1 has no clue how to get that traffic back. So what's happening here right now is that the ping goes out. The ICMP echo request goes out. Router 2 gets it and says, hey, I've got a default route. Router 1 is going to get that traffic and say, totally cool, I've got a default route. And it sends it to the ISP. And the ISP gets it and says, yep, I know that that traffic is going to get sent back this way, but it gets to Router 1, and Router 1 says, now the destination network is 10.10.16.250. Well, the destination network is 10.10.16.128/25, but the destination IP is 10.10.16.254. At which point Router 1 says, well, hey, do show IP route. let me look in my routing table. Do I have a route to get to the 10.10.16.128 network? I do not. And that is the problem. And so it does have a static route. And so what is router 1 doing with that traffic right now? Yeah, it's sending it right back out its default route, its default gateway, the gateway of last resort, out that serial interface to the ISP, who then says, nope, going to send it back to you because that's what I know how to do. That's what I know to do with that traffic. And then router 1 says, nope. And you can see what we've got going on here. There is your loop. And in fact, I haven't looked at this ISP router yet, and we can't get there. So my guess is the ISP has static routes to get to the 10.10.16/24, which includes both of these networks, and maybe a static route to get to the transit segment here. So, but we can't get on there, but rest assured, it's going to be able to get us back. So router 1 right now doesn't know what's going on. So that is our final IPv4 static route, is we have to tell router 1, hey, here's how you get to that 10.10.16 or those 10.10.16 networks. So we're going to say IP route 10.10.16, whoops, that's 16.0. Now, could I do this, right? Could I say 128 and then do the first network and then do a second static network entry for this LAN segment over here? In other words, could I do one static route for this network as a /25 and one for this network as a /25? Yeah, sure, absolutely. But why would you do that when you can simply have a single /24 network entry? This is the best practice. If you're going to be having to enter in 2 static routes, right, on router 1, and there's only one way to get there, why not represent both of those /25s as a single /24? Because again, there's only one interface out which we can go to get there. So now let's go ahead, let's test our connectivity here, and let's see if what we did is oops, sorry, I didn't want to move it. I wanted to make it a little bit larger there. And let's see if we did what we were supposed to do. So 64.100, 100.1. And take a look at that. We've got full reachability in the network right now. Let's come over to PC2, where before we were seeing that things were timing out. It wasn't working. However, now we've got connectivity because now router 1 knows how to get back, right? Because remember, you got to think of routing as not just unidirectional, right? Routing is a bi-directional kind of a problem, a challenge that we're trying to solve. We have to know how to get there, yeah, but we also have to know how to get back, right? What is my destination path, but then what is my return path to get back to the network segments? All right, guys. Well, it has been an amazing semester. I've really enjoyed our time here with the CTS-131 and the SRWEv7 course curriculum. 16.3.1 was the last Cisco Networking Academy packet tracer. This is our last homegrown skills packet tracer activity, skills number 4. As always, thank you guys so much for watching, and thank you for all your work this semester. And as always, I hope to see you guys in the next video.